This video discusses the rhombus and problems that are related to it. We're going to go ahead and talk through the properties of the rhombus and then jump to problems where they actually show up. So we're going to be doing 6A and 6B kind of as we are talking about the properties of the rhombus. We're going to first focus in on the side and angle properties of a rhombus. So from a parallelogram, we see that we get that opposite sides are parallel. The rhombus is a form of a parallelogram, so we see that we have opposite sides being parallel. And we also get the property that opposite sides are congruent. Now, one addition to this, though, is not only are opposite sides congruent, but we have 4 congruent sides. So this is a new property that we haven't seen up to this point. That again. Is that we have 4 congruent sides. So a square has 4 congruent sides, but that actually comes from this idea of the rhombus, where we have 4 congruent sides. So if we take a look at 6B, we are given side lengths of BC and CD, and we know that BC is congruent to AD up here, and we also know that CD is congruent to AB, but we also know that BC is congruent to CD, so we can set up the relation. That's 7y minus 8 is equal to 41. So solving this two-step equation gives us that y is equal to 7. All right, next property that we have of a parallelogram is that opposite angles are congruent. We get that, from a rhombus, that we actually get from a parallelogram is that opposite angles are congruent. We see here that this green angle is congruent to this green angle, and this gray angle is congruent to this gray angle. That'll actually come and help us out as we talk about 8A. So we know that this whole angle down here with angle X is congruent to this whole angle here with the 55. So angle A is congruent to angle C, the whole angle that's listed there, as well as we know that angle B is congruent to angle D. That doesn't help us directly off the bat, but we know they are equal. And additionally, we also get that property from a parallelogram that consecutive angles are supplementary. All right, so this whole angle, angle B plus angle A should equal 180 degrees and other combinations. Now, it's really the diagonal properties that really help us solve the rest of these problems and come into play a lot. We know that the diagonals are perpendicular to each other. The diagonals are perpendicular to each other, which means that they form right angles. I'm going to zoom in on this picture here. The diagonals are perpendicular to each other, so that means we get 4 sets of right angles happening right in the center intersection point of our diagonals. Additionally, the diagonals bisect each other. So we have this piece of the diagonal being congruent to this piece, and this piece being congruent to this piece. That is actually plays in right here. In 8B, we see that, hey, I have the diagonal of a rhombus. And we know that this piece of 11 is congruent to this piece of 2x plus 3. So we can set up the relationship that 2x plus 3 is equal to 11. Solving this two-step equation gives us that x is equal to 4. The last 2 properties of a diagonal are pretty important. They kind of go hand in hand here. Diagonals bisect angles as well. So what that means is, as you can see in my diagram, this angle down in my lower corner, it is actually cut in half. So this piece is congruent to this piece, and we know that opposite angles are congruent, so that means that this piece is also congruent to this piece. So we know that the full angles are congruent, as we had up here, so the green angle is congruent to the green angle, but we also know the diagonal cuts it in half. We can see that happening right here, that this open angle here is congruent to this open angle here. This open angle is congruent to this open angle. And what that also does, in kind of working with the idea of the perpendicular angles, is we have what we form is 4 90-degree triangles, or we could say we could form right triangles. I'm going to come up in here and actually shade in one of the right triangles we see here. This is in fact one of our triangles, forms 90 degrees from the perpendicular. So we have a right triangle, or just a triangle in general. Whenever we have, and we can see that we have, this happens in 3 other locations as well. Whenever we have triangles, we also need to remember the Pythagorean theorem, since it's a right triangle, may come into play, as well as the triangle sum theorem, that all the angles inside of a triangle add up to 180 degrees. Though that is actually going to take into place or to help us in y. So let's go ahead and finish off 8a. I have to figure out the values of x and y. So for x, well, I know that opposite angles are congruent, but I also know that the diagonals bisect each of the angles. So if this angle is 55, that also means that this angle is 55. And that means that this angle is also 55, which means that this angle is 55. So we know that x is equal to 55 degrees. Again, coming from the combination that we know opposite angles are congruent and the diagonals bisect those angles. So all 4 of those angles that are there are congruent. So in this case, they are all equal to 55 degrees. Now, we also know that at the intersection of our diagonals, we have perpendicular. They are perpendicular, which means we have 90 degrees. And if we look a little closer, we should actually see that we have a triangle between B, C, and my intersection point, which I've highlighted here for us, which means that we can actually use our triangle sum theorem to set up the relationship that y plus 90 plus 55 is equal to 180 degrees. Combining like terms and solving this equation gives us that y is equal to 35 degrees. We saw a problem like this on our exam where we had to know that the opposite angles are congruent, but also each angle is bisected, and as well as a triangle sum theorem occurring. Got to see the forest through the trees, or the triangles in the quadrilaterals here. Got to see those as we're going through. They pop up a lot. Additionally, on the review, we saw that there was a Pythagorean theorem problem that we could potentially do as well. These show up all the time through these quadrilaterals, specifically with rhombuses, as well as rectangles, which we'll get to in a bit. Got to be wary of that. There probably will be another one on the retake for you. So make sure we're looking at that. If you need any additional questions, please ask me in class.